Hello everybody. In this series of videos we will be preparing for the midterm exam, and I have just picked a few more difficult questions from the review that I did, and so I will be doing those in this video series. And just let me know through Ivy Learn or an email if there's a specific question that you have that I haven't covered in these videos, and if I have time I'll create a video for that as well. So we're going to go ahead and start off with an optimization problem, and it says to minimize the paper used for a rectangular poster whose printed area is 36 square inches with 4-inch margins. So in any one of these questions, let's go ahead and start off with a picture. So here's our poster here, and we have an inner rectangle, which is the printed area. So that area right there should be the 36 inches squared. And so we're going to have two different variables in this problem. We're going to have x and y, where I have defined x as the width of the printed area and y as the height of the printed area. And of course, we know that we're going to have 4-inch margins. So from here to here is going to be 4. From here to here will be 4. And then we'll have the same thing on the other sides. So it looks a little something like this. So we want to minimize the total paper used. So the equation that we're going to be minimizing will be the area of this entire rectangle, because that's the total amount of paper. So the area of that would be, of course, the width times the height. So the width would be x plus the two 4-inch margins. So that width would be x plus 8. And similarly, the height would be y plus 8. So our total area is x plus 8 times y plus 8. Now, we have the equation that we want to minimize, but in any one of these optimization problems, we'll typically have two variables. So we have to figure out some way to substitute in for one of those variables. So we have to figure out the one other piece of information that's been given to us, and that's, of course, that the printed area is 36 square inches. So we know that the printed area is 36, but we could also set that equal to x times y in terms of our variables. Now we simply solve for y or x, and we can plug it in to the area. So I'll solve for y. It doesn't really matter either way. And now y equals 36 over x will be plugged in right here. So now we've got the area equals x plus 8 times 36 over x plus 8. So now we've got the function that we're trying to minimize in terms of a single variable. So as you may remember, all we have to do from here is take the derivative and set it equal to 0. We could take the derivative right now. We'd have to do kind of a nasty product rule. So here, just to make things a little simpler on us, let's just go ahead and FOIL this out. It'll make our derivative a little bit easier. So if we FOIL this out, I'll let you do this on your own, but you'll get 36 plus 288 over x plus 8x plus 64. Okay, and then we'll take the derivative. Of course, these constant terms, 36 and 64, go to 0. 288 over x, we could always think of this as 288 x to the negative 1, which will save us a quotient rule. And so we take that power, we put it in front, negative 288, and then we decrease the power by 1. Right, so negative 288 x to the negative second And then the derivative of 8x, of course, would be 8. Now that we have the derivative, all we have to do is set that equal to 0, and we will be able to solve for our x. So just rewriting this a little bit, we'd get negative 288 over x squared using one of our exponent rules. We can also move the 8 over to the other side. And when you guys solve for x, again, for the sake of time, I'll let you do that on your own, we would get x is equal to 6. Okay, so if x is equal to 6, what's y equal to? Well, we already have y in terms of x up here. So if we plug x into that equation, we would get y equals 36 over 6. So y would equal 6 as well. So the way to minimize the total paper used for this rectangular poster would be to have x equal 6. So the width of the printed area be 6, and the height of the printed area be 6. Now, be careful here because sometimes the question will ask something like, what is the total area of the poster if we minimize the paper used? So if it asks something like this, we just have to plug x and y back into our area equation and we could figure that out. So just make sure that you're answering the end question in mind. All right, I hope this is helpful. If you have any questions, please let me know. I'd be happy to shoot you a message back and explain anything that didn't make sense.